Hello everyone, welcome back to our YouTube channel schoolquiz.com. And my name is Danish Agarwal. Today we will discuss chapter number 4, that is structure of atom, in which today's topic is Rutherford's model of an atom, which is very important. Rutherford's model of an atom. Okay. Now today's topic is Rutherford's model of atom. Another fourth model of an atom. As we have started with chapter number 4, that is what? That is our structure of atom. Structure of atom. I have already made one introduction video on chapter 4, structure of atom, in which we have already discussed what the actually atom is and the very important model, that is Thomson model of an atom. Next we will proceed to our Rutherford model of an atom, which is very important from the paper point of view. From the very important from the paper point of view, and it's very important. So now we will discuss Rutherford model of an atom. And it is also known as, and its another name is planetary model. Planetary model. Rutherford model is also regarded as planetary model, and it takes the credit of discovery of nucleus. Discovery of nucleus credit goes to Rutherford model of an atom. This Rutherford model of an atom. As we will discuss our topic Rutherford model of an atom, now I will tell you why it is regarded as planetary model. Okay, I will let you know in our later video. Okay, now we will start. It's very important. It is a discovery of nucleus also main highlighting points. First of all, in his experiment, he take gold foil. And these are the atoms of gold. These are the atoms of gold. Suppose this is our gold foil. First question arises, why he took the gold metal for his experiment. Why he took the gold metal for his experiment? So its answer is what? That, as we know, metals are malleable. Metals are malleable, and it can be converted into thin sheets. And as we know, gold is a highly malleable metal. Why he taken gold? As we know, because metals are malleable and they can be converted into thin sheets. In which atoms can be converted into thin sheets. So that's why he taken gold metal for his experiment. It is also one mark question. So note it down. Okay. Now he strike the alpha particles. He strikes the what? Alpha particles. And alpha particles are what? Alpha particles are helium nucleus. Alpha particles are helium nucleus. It is He242 plus. He242 plus. As we know, He2 means there are two number of electrons. And positive charge indicates loss of electrons, and and there are 2 plus charges present, 2 plus charges present, it means 2 electrons are removed, 2 electrons are removed, or 2 electrons are lost by the atom. So as there are no number of electrons, so that's why it is regarded as helium nucleus. That's why it is regarded as helium nucleus. That's why it is regarded as helium nucleus, because there are no number of electrons. That's why they are regarded as helium nucleus. As it is a nucleus, so we can write it as alpha particles are positively charged. Alpha particles are positively charged. Alpha particles are positively charged. Okay. Now he made alpha particles strike from a radioactive source. Like, most of the, observe this experiment carefully. Observe carefully. What do you observe? What do you observe from these red lines? These are what? These are our alpha particles. These are what? These are our alpha particles. What do you observe? First point is observations. We will write it one by one. First observation is most of the alpha particles, most of the alpha particles, most of the alpha particles went straight without any deflection. Most of the alpha particles went straight without any deflection. Suppose this is a wall. Suppose this is a wall, and this is our, suppose it is our wall and it is our ball. Okay. If I strike it like that, if there is nothing, suppose there is not a wall, it will pass through that. But if there is a wall, it will strike and bounce back. It will strike and bounce back. What it shows, if the alpha particles are went straight without any deflection, it means most of the space inside the atom is empty. As we strike alpha particles and they went straight without any deflection, it means most of the space inside the atom is empty. It means most of the space inside the atom is empty. First observation is that, and second observation is some alpha particles deflect at certain angle. Some alpha particles deflect at certain angles. Some alpha particles deflect at some alpha particles were deflected at certain angles. Some alpha particles were deflected at certain angles. As we know, alpha particles are what? Alpha particles are positively charged. Alpha particles are positively charged. As we see, they are deflected. So something here is present. So something here should be present. Like these all are atoms. Okay. Something should is present there. That's why they are deflected at certain angle. Na? If something is present there, that due to which deflection occurs. So as alpha particles are positively charged, so there must be any charge present. So there must be any charge present. Okay. Third point is Third point is one atom, one alpha particle, one alpha particle deflected back. One alpha particle, one out of 1200 alpha particles, one out of 1200 alpha particles were were deflected at 180-degree angle. Were deflected at 180-degree angle. So as the repulsion occurs, suppose as the repulsion occurs, it means it is positively charged. It means it is also positively charged. That there must be positive charge there. That there must be positive charge there. If there is negative charge, they will attract each other. But as the positive charge is repelling, as the positive charge is coming back, it means there must be a positive charge. It means there must be a positively charged. There must be a positive charge, which was regarded as nucleus. Now we will draw conclusions. Of the experiment. What we conclude from that? First one is that what we conclude that most of the space inside the atom is empty. Most of the space inside the atom is empty. First of all, he discovered what? He discovered nucleus. So first point is there is a positively charged species which was termed as nucleus. Because it's a positively charged species which was termed as nucleus. As we know, one more thing, as we know, mass of the electron is negligible. Mass of the electron is negligible as compared to mass of proton or neutron. As we know, mass of the electron is negligible as compared to mass of proton or mass of neutron. So we can say that mass of the atom lies in nucleus. Mass of the atom lies in nucleus. As three things are present like electron, proton and neutron, and its mass is negligible. So it means that whole mass lies in the nucleus. Whole mass of the atom lies in the nucleus. Remember that thing. That mass of the electron is negligible. So we can say that the whole mass of the atom lies in the nucleus. Now we will discuss our second conclusion. Second conclusion is the electrons revolve around the nucleus. Electrons revolve around the nucleus. How did he conclude that? He compared he compared the structure of atom with with planet system, with solar system. We can say that, like planets revolve around the sun, like planets revolve around the sun. So he compared his model with the solar system. That's why his model is regarded as planetary model. That's why its model is regarded as planetary model. And third thing is the size of the atom. The size of the atom is very small, is very small as compared to the size of the size of nucleus. The size of nucleus is very small as compared to size of atom. Approximately there is a difference of 10 raised to power 5. 10 raised to power 5, that is 1 lakh times. That is 1 lakh times. As we know that most of the alpha particles went straight. Most of the alpha particles went straight. It means that most of space is empty and nucleus is like small. So we can say that the size of nucleus is very small as compared to the size of the atom. So this is all about Rutherford model of an atom, which is also regarded as planetary model, and it takes the credit of discovery of nucleus. And he, in his experiment, he took the gold foil. Why he took the gold foil? Because as we know, metals are malleable, and gold is highly malleable. And he made the alpha particle strike, due to which from his observations, he observed that most of the space inside the atom is empty, and there must be a positively charged body, due to which alpha particle is coming back. And the size of the nucleus is very small as compared to the size of the atom. And he also compares his model with the solar system, that as planets revolve around the sun, electrons will revolve around the nucleus around the nucleus. So there was some limitations of Rutherford model of an atom, which was removed by Bohr model. So we will discuss limitations of Rutherford model of an atom in our next video, and Bohr model also in our next video. So I hope this topic clears to you. If you have any doubts still, comment in our box section, so we will remove it. We will try our best to solve your queries. So all the best to you students. Thank you.